In this video, we're going to talk about increasing, decreasing function test. So we're going to use the first derivative of a function to determine whether the function is increasing or decreasing on a given open interval. So what we have to assume here is that f is differentiable. That means we can compute the derivative of. Now, if the derivative of a function f prime, this is f prime, is positive on AB, the open interval AB, then f, the original function, this is the original function, is increasing. So if the derivative is positive, then the original is increasing. If the derivative here is less than 0, is negative, then the original function is decreasing. So when it's positive, it's increasing. When it's negative, it's decreasing. Derivative positive, f is increasing. Derivative negative, then f is decreasing. Now let's go over an example and see how we can apply that. So example, we want to determine the open intervals on which f of x equals 2x cubed minus 9x squared plus 12x minus 5 is increasing and I shouldn't say and or decreasing, is increasing or decreasing. Okay, that's the correct wording. Now, how do we solve this problem? The first step is find the critical values of, so find the critical values of f. Now, if you remember how to find the critical values, you just set the derivative, you set the derivative equal to 0 and solve for x. So let's go ahead and compute the derivative of this function. Very simple. F prime of x is equal to 6x squared minus 18x plus 12. We set it equal to 0. And if we want to solve, we need to factor out. For example, if we find a common factor, which here 6 is a common factor, so x squared should be x squared minus 3x plus 2 equals 0. So if we continue, we have 6 and then x minus 1, x minus 2, and you should verify that this is the proper factorization. So when we set it equal to 0, we get x equals 1 or x equals 2. So these are the critical values. But what do we do with these critical values? So the next step is draw a sign chart. So we have to make a sign chart for f prime. So the sign chart for f prime that we just computed, we computed f prime and we even succeeded in factoring this out. So this is f prime. So we're going to make a sign chart for this. Remember how to make a sign chart? We draw the real number line and we only plot the critical values that we found. We found 1 and 2. Those are the critical values. Now you know what we're going to do next. Picking test points. So for example, here on this interval here, I can pick 0. 0 is in this interval, so I can pick 0 there, and I'm going to plug this 0 into f prime, because it's the sign chart for f prime, not in f, but the sign chart for f prime. So compute then f prime of 0 is going to give you 6 times 0 minus 1 and 0 minus 2. You see that -1 times -2, that's positive, and times 6, that's positive. So this gives you a positive number, because what's interesting here is just the sign. So we have positive over, we have positive here, and we do the same thing. Now let's pick a test point between 1 and 2. So which test point, for example, can we pick? We can pick 1.5, and we're going to compute f of 1.5. What is it equal to? F prime, I'm sorry, f prime of 1.5. It should be 6 times 1.5 minus 1, and then 1.5 minus 2. So I'm using this version of f prime. If you don't want to use this version of f prime, you're welcome to use the raw version, non-factored out version. That's fine as well. But I'm using this because it's going to give me the sign very quickly. 1.5 minus 1, that's positive. 1.5 minus 2, that's negative. Positive times negative is negative. Times 6 would be negative. So that means the sign here is negative. Let me use the red color. So negative. And if you continue here, you pick a test point, let's say 6, you will get positive. But I really want you to go ahead and verify that by yourself. So we have the sign chart. Let us go ahead and erase everything else. Remember, never plot your test point on the real number line. So the real number line will just have the critical values. So that's the sign chart. Remember, this is the sign chart for f prime. And we saw from the increasing, decreasing test that if f prime is positive, the function is increasing. So we're almost done. Here the function is, because we have positive here, f, the original function, is increasing. F is decreasing here, and f is increasing. So conclusion, f is increasing. See, I'm not saying f prime is increasing, it's f. F is increasing on the interval. So I have two intervals, from this interval to that, from this point to that point. That means from negative infinity, I'm looking for the white color, negative infinity to 1, and from 2 to infinity. That's why f is increasing. Now, where is f decreasing? F is decreasing on, we have it here, we have it here in the middle. I shouldn't have used the blue, but anyway, you see what I mean, where the derivative is negative. So it's decreasing on 1 and 2. See, the intervals have to be open, so you have parentheses everywhere. Parentheses here, parentheses there, same on top. So that's how you use the first derivative to determine if a function is increasing or decreasing. Now I'm going to give you a problem for you to work on. So problem, determine the open intervals on which f of x equals negative x cubed plus 3x squared plus 4 is increasing or decreasing. I really would like for you to go through all the steps that I've explained earlier and make sure you find the critical values, you make a sign chart, and you use the test points to determine the sign on the sign chart.